Tool integration often makes our lives easier. Our calendar with our email lets us immediately schedule meetings in response to email requests. Fixing a bug in our code is easier if we don't have to switch between the debugger and the editor. But sometimes integration hides critical testing points that help us understand what is or isn't going on. After all, you can't probe a transistor pin inside an integrated circuit. Hi, I'm Vin D'Agostino. When testing your AI code after integration with your operation code development, it can be difficult to determine if it's working properly. How do I know if my AI is functioning properly? There are 3 things you need to look at. Is my data getting into my training or live set correctly? Is my data processing isolating the conditions I'm looking for to make a decision? And is my classification working correctly in my overall system? We've already reviewed the first 2 in previous videos. The Renesas RAI data collector gives you the highest fidelity between training data and the real-time data because the training data is taken through your own hardware platform. We've also talked about the AI Live Monitor, which gives you real-time performance information about how your models are performing in application. But when it comes to that third point, the answer actually has 2 parts. What is the average inference time? And what is the accuracy of the classification? Renesas has created and integrated a new tool into E2 Studio to help answer those questions. It's called the Hardware in the Loop, or HIL tester. This tool uses simulated data and your selected inference model to show how it runs on your particular hardware. It's important to note that the simulated data is actually derived from your measurements. And if you've used the Renesas data shipper, that data was already taken with your own signal path. At first, the tool looks like it's not doing a lot. That's because the magic is all under the hood. The tool runs your data and different inference engines on it, on your hardware, to answer the questions like, what is the average inference time, the accuracy of the classification, and if it all fits into your available resources. You might think you could do this by hand, and you can, but here's what you'd have to do. Select and download a model from the RAI website. Set up an E2 Studio project yourself to integrate that model. Write the code to set interrupts to be able to measure inference time with an oscilloscope. Write code to send test data to the board over some kind of communication. Run the test. Then do it all over again for a different model. With this tool, you can test each model you're considering simply by selecting it and pressing a button, all without writing a single line of code. Let's take a quick look at the tool. When we open up E2 Studio, we see the same familiar interface. We've already looked at the Renesas AI menu choices in previous videos, but now under Show View, there's another choice called Reality AI Hardware in the Loop Test. This is what we'll look at in this video. But before we can run it, we have to make sure we're connected to our project in the cloud. We do that by looking at the Reality AI authentication window. It says that I have a connection, but you can always test it by pressing Test Connection. Now let's look at the Hardware in the Loop test. That opens up a new tab down here. And you can see a choice for Select Inference Engine. If we browse to our project in the cloud, we can see all of the inference engines that were generated, and we can pick each one and test it. Then we can compare them. But let's start by ensuring that we have the proper connections to the board. You must be connected to the board with your debugging interface, and you need some kind of COM port as a secondary channel for communication. In my case, this is the virtual COM port in my debugger. In my system, that's COM6. We'll go and select the Glass Break project. Then select an inference engine. The Hardware in the Loop test automatically makes an E2 Studio project called HIL_test_ the name of the inference engine. That project is a phantom project that gets deleted at the end of the test. So when I click Start HIL Test, you can see that it immediately switches over to the console view for building the project. Once the build is done, the debug session starts and downloads the image to the target. If we switch back to the HIL tab, we can see that the test is already running. It tells you here the average inference time and the overall accuracy. You can see that early on in the test, the accuracy is 100%, and the inference time is 10.37 milliseconds. But let's let it finish and see if anything changes in our accuracy or inference time. The test is completed, and we can see that we had 10.37 milliseconds as an average inference time and an overall accuracy throughout the test of 95%. I can now use the drop-down and select another one and then run this test again. This lets me quickly run through all of my possible inference engines to see which one would be the best for my project. For more information or a demo, contact your local FAE or sales representative, or visit us on the web at www.renesas.com.